What do you think about this so far, Mike?
I think it looks pretty bad. I mean, it's great. It does seem like one thing, the entanglement is happening between each of the nodes, which is great. It appears as though we see a swap success there, but a lot of the other swaps have failed. And I'm wondering, I know you picked up parameters from the data sheet that we had for this repeater, again, once they eventually become available, and the swap probability was 40% with that particular selection. I'm wondering if we could actually, maybe that's a good repeater, if we could go to a better repeater that has a better swap, probability of swap, or maybe even a best repeater that's got kind of the gold standard of swap probability. Can we upgrade that, pull the specs from that better repeater and load those into the simulation and run this again?
Yes, for sure. Let's go ahead and do that.
Okay.
So, okay, we're saying that we have a better, we're simulating better repeaters. So, okay, let's bring up the probability of success to 90%. So we are simulating better repeaters, and let's change the name of this log file and run our simulation again. All right, it finished running. Let's see what we got this time. So we have our network file, our repeater chain 2 log file, and let's see what happened this time. So scroll down, and okay, we still see some failures. Let's continue to scroll down. But I think we can see more successes than before, right? And then actually, if we scroll down a little bit more, we see how we reached end-to-end entanglement between both nodes, quicker than in the previous example, right?
Certainly, it seems like this is much more successful. As you pointed out, we're getting the entanglement swapping to get Alice and Bob to be completely entangled with one another. Hopping over the repeaters almost. But one of the things, again, I'll pick up here, I think, the fidelity looks a bit lower. I'm sort of accustomed to getting to the higher fidelity that you've given us in the past two use cases. And I wonder, is this, I know that there are memories that are located within the repeaters, and that drives the specification of decoherence time for the repeaters as a whole. And I'm wondering here if maybe we could upgrade the repeater memories, the repeaters, to be not just good, but maybe a better repeater with better decoherence times, or maybe even potentially gold standard decoherence times. And maybe that's another factor that we could pull in here to improve the fidelity and turn this into a network that could genuinely be multi-purpose.
Yes, Mike, let's go ahead.